Okay, we've got an object here. We've got a shape, the blue shape, and we're trying to find the centroid of the shape. X bar and Y bar of the shape. I like to make a guess as I'm getting started, so it helps with the gut check as I wrap up. So based on this shape, I'm guessing my centroid's gonna fall around that yellow dot. Here's a little bit of our plan. Okay, so the plan is to find or establish DA, and that's the little rectangular slice, and we're going to need the elemental centroid of that slice. And then we'll use our equations. The x centroid of the shape is the integration of x tilde dA over the integration dA. And the integration of dA is just the total area. Y bar is the integration of y tilde dA over the integration of dA. Again, the area. So let's start by establishing that rectangular slice. I'm going to draw it right on the picture here. And that rectangle there, that is dA. That is my little slice of my area. I need to know the base and the height. A couple of things up here. This is going to be dx, and that is the base of my rectangle. The height of the rectangle is going to be based on the top edge and the curve at the bottom. The curve is x, y, and that is the location along the curve as we're integrating. The other thing, so we just established dA. Now we need to know where the centroid of that slice is. And that's x tilde y tilde is the centroid of that rectangular slice. All right, let's figure out what those are in terms of numbers. dA, the little slice of area, is the base times the height. The base is dx, and the height is 4 minus y. Okay, so that's the height of the rectangle, and we're basing that off of the top number up here, which is 4, the highest possible y value, and we're going to subtract off the y value as we go along. Now we want to take the y value and put it in terms of x by substituting in this formula. So we're going to rewrite dA in terms of x. dA equals 4 minus y, and y is 4 minus, I like to rewrite this as x squared over 16 dx. I could write this one more time as dA equals x squared over 16 dx. Does that make sense for a height? That it's just x squared over 16? Well, the height of over here when x is 0, right, we have a height of 0. Over at the far side when x is 8, we have 64 over 16 and the height is 4. So that does check at the two numbers that we can confirm at. Next we need to set up what x tilde and y tilde are. X tilde, the centroid of the rectangle as I'm walking along the curve. If this is my value x, x tilde has exactly the same location as x, so x tilde is x. And y tilde is in the center of the height. So we can think of it as height over 2, but that would be just relative to the x-axis. It would be way down here, which isn't right. So it could be h over 2 plus y. I prefer to think of it as the average of the two locations. So we're going to have the two locations as 4 and y, and divide that by 2. Again, we got to put the y in terms of x, so we'll use our equation of the curve here to convert y into x. So y tilde is going to be 4 plus 4 minus x squared over 16 divided by 2, or y tilde equals 4 minus x squared over 32. Okay, so in order to do our math, in order to plug into our equations, right, we've got dA in terms of x, we've got x tilde in terms of x, and we've got y tilde in terms of x. Let's set that up. X bar, the centroid of the entire shape, is the integration from 0 to 8 of x tilde, which is x, times dA, which is x squared over 16 dx. And we are going to divide that by the integration of dA, which is 0 to 8, of x squared over 16 dx. Now this is statics, this isn't a calc class, so go ahead and use those calculators and plug in these values. And let the calculator do the definite integral for you. We end up with 64 divided by 32 over 3, or 6 meters. So if I come back to my original estimate, I might have drawn it a little bit too far to the right, but we have 6 meters as the x, the overall blue shape, its x location for its centroid is 6 meters. All right. Let's set up the same thing for y bar. Y bar equals the integration from 0 to 8 of y tilde, which is 4 minus x squared over 32 times dA, x squared over 16 dx. And we're going to divide that by the integration of dA, but we've already figured that out. So when we integrate, again, you don't have to do any, you can distribute this out, but you don't need to. And I calculate this to be 29.87 divided by that 32 divided by 3 is 10.67, and I end up with 2.8 meters as my y bar location. So if I add that on here, I have 2.8 meters as the location of the y location of the centroid of the plate. Even though we only drew one rectangle, we solved everything in terms of x, but we are still able to solve for both the x centroid and the y centroid using the same slice.